Hello and welcome to my IGCSE, all of IGCSE 0580 video. So there's been a lot of preparation going into this. I know a lot of you have asked for this kind of video. And what I've really done here is boiled it down to a top 10 list of topics. So these are the most certain topics from my prediction videos. If you haven't checked out those prediction videos, then do check the video above. Again, I'll go through the most common topics. And I've picked out the top 10 here to really help you supercharge your revision. Okay, so number one is percentage calculations. And this can take a variety of different forms: reverse percentage change, compound interest, and comparing multipliers. So I go through a question exactly like that. Okay, and on to a very typical IGCSE 0580 question on percentage calculations. So, in a sale, all prices are reduced by 15%, and Yasmin decides to buy a blouse with an original price of $40, and we actually want the sale price of the blouse. So we want to take 15% off $40. And the easiest way to do this is to first of all work out 10% of $40. Well, what we do here is do 40 divided by 10. That gives us $4. Then we can work out 5%. So let's think, how do you go from 10% to 5%? Well, we divide by 2. So we do the same to both sides. $4 divided by 2 gives us $2. And now by adding these together, we can then get 15%. So 15% will be $4 plus $2 equal to $6. However, this is not the final sale price. Remember, the sale price, well, this will be equal to the original price, which was $40, and then we take off this 15% discount. So we take off the $6 here, and if we do that, then we get our answer of $34. Notice I'm showing my working really clearly so I can guarantee all 2 marks. B is slightly different. So Zach decides to buy his own shirt with a sale price, this is important, of $29.75. And you want to find the original price of the shirt. As soon as you see this, then there should be alarm bells going off, because this means it's a reverse percentage change question. And this is a higher level skill to master, reverse percentage change. So let's think about this. If you start with 100% and you take off 15%, well, you're left with 85%. And what this question is saying is that 85% of the original price is equal to $29.75, and we want to find the original. So we want to find 100%. So we need to go through a couple of calculations here to work this out. Now, the most straightforward approach is the so-called Unitary Approach. So what I'm going to do is divide by 85 on both sides. Notice that 85 divided by 85 is just 1. So I work out the price for 1, and then how do I go from 1 to 100? Well, I multiply by 100. And I have to make sure I do the same process on both sides. So let's go over to my calculator now. We're going to take the right-hand side now, divide it by 85, and times by 100. We type in 29.75. Divide that by 85 and then times by 100. We don't have to worry about bid maths here, and we see we get our answer here of 35. So we can then just pop in our answer of $35 like so. But you must show your working to make sure you've made clear to the examiner that we have a reverse percentage change question and you know how to do it. So on to part B. So Xavier's salary increases by 2% each year. Not too bad, and in 2010 his salary was $40,100, and we want to calculate his salary in 2015. Give your answer correct to the nearest dollar. Notice I'm underlining the key part of the question. So if we increase something by 2%, well, we're taking the 100% and then we're adding 2%, and that gives us then 102%. My next step is to change this into a multiplier. So what I do here is divide by 100 to get it as a decimal. So if I do 102 divided by 100, let me just pop that there, then I get this crucial number here of 1.02, which I'm going to use for the rest of the calculation. Now, in order to work out this increase, remember it's compound interest essentially, is what's going on here. So our answer is going to be his original salary, 40,100, multiplied by, you got it, the multiplier, 1.02. And now we need to think the amount of years has gone. So 2011, 2012, 2013, 2014, 2015. That's 5 years. So we need to put a small 5 up here. And this is the calculation we're going to do to work out his new salary. Let's go to the calculator and do it. So we type in 40,100 multiplied bracket 1.02 close bracket to the power of 5. And now we get our answer. Remember, this is to the nearest dollar here, so I'm going to write it to the nearest cent first of all. So 44273.64. 44273.64 ... And then we want to round to the nearest dollar. So let's think, is it closer to 44,273 or 4? Well, we've got 6 here, so we're going to round upwards. So we get 44,274. And now we need to work out in which year is Xavier's salary first greater than 47,500. Well, let's use the information we've got at the moment. So 2015, we've got 44,274. And we just want to work out when it crosses this threshold. So I'm going to go to my calculator, keep multiplying by 1.02, and just keep track of exactly how many years I need to go along in order to work out when it crosses this threshold of 47,500. We take the previous answer here, and then we just go times 1.02, a trial and error approach. So this time we get 45,159. So I'm going to write that in for the examiner, 45,159. And we just keep doing this process until we get this critical value of 47,500, making sure we keep track of how many years have passed. So let's go back again. 2016, so let's just keep multiplying by 1.02. This is 2017, 2018, and finally 2019. So the answer is going to be 2019. And what I do for the examiner here is just show that very final value that we've got here. So again, you've still got this process of timesing by 1.02. And let's just go back and check that final answer. It was 47,923. So I'd certainly show the examiner that I did work this out. 923, and this is of course more than 47,500. So just being really clear to the examiner, guaranteeing those 3 marks. A slightly different question, which I thought was quite interesting here. So read this carefully. In January 2020, the population of a town was 5% more than its population in January 2018, but then in 2021, the population of the town was 2% less than its population in January 2020. And we want the overall percentage increase in the population. So the way we do this, let me draw a little diagram out here. So we've got 2018, then we get to 2020, and then finally we get to 2021. And what they're basically saying here is we had a 5% increase. Now if you remember that process that we did before, so 100% plus 5% is equal to 105%, and then this as a decimal is 1.05. So here they're saying the percentage increase or change is times 1.05, and between 2020 and 2021 is 2% less. So we do a very similar calculation, but notice it's 2% less, so we go minus 2%. That gives us then 98%, and then as a decimal that's going to be 0.98. So what's going on here is we increase by 1.05 to go from 2018 to 2021, and then we've got a multiplier by 0.98, a decrease in effect from 2020 to 2021. And what we want to do is go directly from one to the other. This is actually easier than it looks. The way we do this, so to get our answer, is we just take these two multipliers and multiply them together. So we just do 1.05 times 0.98. This is where the calculator comes in. 1.05 times 0.98, and that gives us 1.029. And all we need to do at this point is convert that back into a multiplier, so 1.029. If we do the backwards process here, we just take these two digits, so we just take this as 2.9%, which is going to be our answer. Please do check the mark scheme and make sure that you're happy with exactly what I've done. This is a really crucial topic for your general understanding of 0580 maths. And my second topic is non-calculator fractions. Comes up more or less every year on paper 2, and this is a typical question that I'm going to go through now. Right, question 8. So without using a calculator, so we need to show our working to get our 3 marks, we need to work out 1 3/8 minus 5/6. So step 1, I'm going to change the 1 3/8 to an improper fraction. So 1 times 8 is equal to 8. 8 plus 3 is equal to 11. So I can rewrite the first fraction as 11 over 8 minus 5 over 6. So that's our first step. Write it as an improper fraction. Step 2, we need to find a common denominator. Now we could times them together and do 8 times 6 is 48, but there is a lower common multiple, which is 24 instead. Notice 8 times 3 is 24, 6 times 4 is 24. So 24 also works, and we'll keep the mathematics, the arithmetic, a little bit easier. So we want to change each of these fractions into out of 24. Well, what do we multiply 8 by to get 24? We times by 3, so we have to do the same to the top. So 11 times 3 is equal to 33. What do we do to 6 here to get to 24? Well, we're going to multiply by 4. So then we do 5 times 4 is equal to 20. And once we have the fractions the same, so both out of 24, we can simply just minus the numerator and leave the denominator alone. So if we minus these fractions, 33 minus 20 is equal to 13. And that's our answer, 13 over 24. By taking 24 as our denominator and not 48, we avoid having to do some simplification at the end. So it makes our life a little bit easier. Just to recap, we change this to an improper fraction, 1 3/8 to 11/8. We find the lowest common multiple or lowest common denominator, which is 24, and then we change the numerators accordingly and then get our answer. Very nice. This also always comes up, by the way, on the 0580 paper. It's literally my number 1 topic when it comes to my predictions. And number 3 is generally a paper 4 topic, which I call quadratics. And this can take a variety of different forms. And I take a typical question. Okay, so I'm going to go through a typical quadratics question, and these can come in many different forms, and this also allows me at the same time to cover a little bit on speed, distance, time, which, even though it doesn't make my top 10 here, also comes up pretty often. So Alicia walks a distance of 9 kilometers at a speed of x kilometers per hour, and then she ups it a little bit and then runs the last distance of 5 kilometers at a speed of 2x plus 1 kilometers per hour. And the total time Alicia takes for the whole thing is 2.5 hours. And somehow, from this information, we need to work out this quadratic, which seems kind of random. Now let's remind us, first of all, what the speed, distance, time triangle is. So this is something that you should be familiar with. So speed is equal to distance over time. And what we want to focus on here is specifically the time, because we want to work out the total time taken. So by using this triangle, we can see that time is equal to distance over speed. So what we're going to do here is we're going to work out the time taken for the first part, the walking, and then the second part, the running. So if we look at the first part here, distance over speed, well, that's going to be equal to 9 over x, because 9 represents our distance, x represents our speed. Then we're going to add on the running part. So the running part, time taken, is distance, which is 5, over the speed, which is 2x plus 1. And we're told that the sum of all the time taken is equal to 2.5. This is probably the hardest part of the question, taking the information given and then writing it in terms of an equation. From that, we're now going to use some of our algebra skills to make our quadratic. So we're going to make a common denominator. Now the general way that we do this is we times the two denominators together. So that's what we're going to do here. We're going to multiply x by 2x plus 1. Now we need to work out what goes on the numerator, and we're going to use this cross effect here. So in order to work out the numerator, we multiply the 9 by 2x plus 1 and the x by the 5. If we do that, we get the following calculation: 9 lots of 2x plus 1 plus, well, 5 times x is just 5x, and that's equal to 2.5. So we're making progress here. We're just going to be very patient and take our time. So what we're going to do now is remove the denominator. That's kind of ugly. So what's the opposite of dividing by x times 2x plus 1? Well, we're going to multiply by x lots of 2x plus 1 on both sides of the equation. This is where your x's and your timeses need to look very different to help you.
Mr. Dickinson, please come to the school office. Thank you.
So if we do that, then this is going to cancel here. That then gives us just the numerator. So 9 lots of 2x plus 1 plus 5x is equal to 2.5 lots of x lots of 2x plus 1. And now it's a case of expanding those brackets out and then simplifying. So if we expand the bracket using the hook, we get 9 times 2x is 18x, 1 times 9 is 9, 5x stays the same. Let's be a little bit careful at this point. 2.5x times 2x, or 2.5 times 2 is 5, x times x is x squared, and then we have 2.5x times 1, that's just 2.5x. We're making progress here. Do not worry, it doesn't look like the answer at the moment. Now I'm going to collect up like terms. So 18x plus 5x is 23x plus 9 is equal to 5x squared plus 2.5x. Now I'm going to use a kind of a slightly lazy approach here. To get rid of this decimal, I'm going to times both sides by 2. So I get everything as an integer. And I need to make sure I multiply everything by 2 here. So 23x times 2, that's 46x. 9 times 2 is 18. 5x squared times 2 is 10x. 2.5x times 2 is 5x. And we're almost there. We're going to bring everything to the right-hand side. So I'm going to minus 46x from both sides. So if I do this, almost there, I get, well, this cancels. Woohoo! That gives us 18 equals 10x squared. Now, plus 5x minus 46x, that's going to be minus 41x. And you can see we've almost got our answer here. We minus 18 from both sides. And I'm going to write this over here. So if we minus 18 from both sides, we get 10x squared minus 41x minus 18 is equal to 0, which is what we wanted. This is exactly the equation that we wanted. So it's all about being very patient through the algebraic process here in order to get to the right answer. Now let's have a look at part 2. We want to work out Alicia's running speed. So just to be aware, the running speed is this one here, the 2x plus 1. Now before we can do that, we need to work out what x is. So we're going to use the quadratic formula for this one. Now this is on your formula sheet, but just a reminder, x is equal to minus b plus minus the square root b squared minus 4ac all over 2a. In German, we call this the midnight formula because you need to recite it if you woke up at midnight. Now, what is B, A, and C? What are these numbers? So, I'm going to highlight this for you now, or underline it. So this number represents the A, this number here represents the B, and this number here represents the C. So we're going to substitute these numbers into the formula. So A is equal to 10, B is equal to minus 41, C is equal to minus 18. And we're going to put all those in. Well, let's be careful about it. So x is equal to, well, minus b, so minus 41 is plus 41, plus minus b squared, so minus 41 in brackets, all squared, minus 4ac, so 4 times 10 times minus 18, all over 2a. Well, a is 10, so 2a is going to be 20. Now, because we're looking for a running speed, it always has to be positive. So at this point, I'm just going to look for the positive answer of this. So I'm going to look for x1, which is 41 plus the square root of minus 41 squared minus 4 times 10 times minus 18 all over 20. So this is where the power of my calculator is going to come in. Let's pop this into my calculator. Okay, so now I've got a fancy calculator here, but again, any calculator will do this calculation for you. So we're going to put in 41 plus, now we need the square root, and then we've got our brackets, minus 41 brackets squared, minus, brackets are very important here, 4 times, let's just double check, 4 times 10 times minus 18, minus 18, close bracket, and now we want this as a fraction. Okay, undo, come out of this as a fraction, 45. I want the whole thing as a fraction, so I'm just going to do a little bit of modification here to make sure that we get the whole thing. 41 plus, all over 2a, that was 20. So I'm just making sure that this here looks exactly like what I've written here. So 41 plus minus 41 squared, this thing here. Always double check what you're doing here, and if you press the enter button, we get our answer of 9 over 2. So using our calculator, we get this answer of equals 9 over 2, which is positive, which is all good. However, this is not the final answer. This is just the answer for x. So to get the running speed, this is where people often fall down on marks. They don't do the entire question. We want 2x plus 1. So we want 2 lots of what we just worked out, 9 over 2 plus 1. Well, these two cancels. We get 9 plus 1. And then we get our final answer of 10 kilometers per hour. You can have a look at the mark scheme. So you've got CI here, so you can see exactly where we pick up the marks. And then C part 2, this is our final answer of 10. Remember to do that very last part, which is to work out the 2 times this 9 over 2 plus 1. That's really, really important. Okay, so that is the quadratic section of this video. So make sure you go through this really carefully. I've gone through the quadratic formula. I've also gone through how to go from a worded question to the quadratic, which is a really important skill on 0580. And number 4 can appear on paper 2 or paper 4. It is 3D Pythagoras and Trigonometry. Again, it comes up very, very often, and I go through a very typical question. Okay, now let's look at a very typical 3D Pythagoras or trigonometry question. And this is a classic from a 2021 paper. So, diagram shows a prism, A, B, C, D, E, and F, and we're given the various dimensions. And just be aware that this is a right angle. In fact, later on, we also need to be aware that this is also a right angle here as well. And we need to work out the total surface area of the prism. Now, we're going to find that very difficult unless we find this side here. So we find this side BC. And we can use Pythagoras to actually work this out. Now, with my students, generally, I recommend if you can write this in one easy calculation, it makes your life a lot easier. So We can use Pythagoras on this to work out BC, and remember that's going to be the square root of this squared here, the hypotenuse, minus the shorter side squared. So we can work this out in one smooth calculation, as BC is equal to the square root of 20 squared minus 13 squared. So I'm going to go to my calculator and work this out. So I have my normal calculating view. I go to Control, square root of 20 squared minus 13 squared, and I get this long decimal of 15.2. Now one thing you can do on your calculator is actually store this as a variable, so I'm going to store this as A, so every time I type A, I have this very long decimal. However, I'm going to show the examiner I have worked this out, so I'm going to put 15.19 ... and I'm going to use that for the rest of the calculation. Now to work out the surface area, we're going to do this in a variety of steps. So first of all, I'm going to work out the triangle. So I'm going to work out the triangle, let's call this B and C. So the area of B and C together is going to be base times height. Well, we don't need to divide by 2 because we've got two triangles. So this is going to be 13 times that 15.19 ... Now I'm not going to work out anything on my calculator until I've established every single area I need to find. So now we can find out the area of the rectangle at the back. So the area of D, well this length here is 24, this is 13. So I'm just going to write this down clearly for the examiner. Now I'm going to work out the base, let's call that E. So the base is going to be 24 times that 15.19 we worked out earlier. So the area of E is equal to 24 times that 15.19 ... And then finally, I've got the slanted part as well. So don't forget that part too, that's important. So the area, say, of F, so the slanted, is equal to, well, that's going to be 20 times 24. So notice for the examiner, to make sure I'm picking up all these method marks in case I go wrong anywhere, I'm writing down very clearly how I've worked out each of the different parts of the triangular prism. So the total, so the final answer, is going to be the following. It's going to be 13 times the 15.19 ... plus 24 times 13 plus 24 times 15.19 ... plus 20 times 24. So notice I've written that down very carefully. Now it's time for my calculator to do its job. Right, now remember I've stored this big decimal as A, so I'm going to use A for that decimal. Let's get started. So we've got 13 times 15.19. So we go 13 times A. Now A is going to come up as a bold letter because I've assigned it a value. Right, now let's look at the next part. So we've got 24 times 13. So just taking my time, making sure I'm typing everything in. There we go, plus, let's see what's next. So we have 24 times 15.19. So let's go 24 times A. Remember A is representing that long decimal. I've got one more to put in here, 20 times 24. Nice easy one. So 20 times 24, close bracket, and then I get a very clear answer of 1354.35. So I'm going to write that down. And generally we like rounding to 3 significant figures here. So this to 3 significant figures. Again, we're going to round after the 5, therefore it's going to be 1,350. 6 marks is a lot on any IGCSE exam, and you can see by just being careful, by showing my working, not only have I got all 6 marks here, even if I didn't, I can pick up lots of method marks on the way as well. Right, then we go on to part B, so we want to work out the volume of the prism. So remember, if you did a cuboid, generally the volume would be length times width times height, but we've got a triangular prism, so we want to divide that by 2. So we're going to type in volume is equal to, so 13 times that 15.19 long number, times the length, which is 24. Again, you can do this in any order. The order doesn't matter. Let's go to the calculator and work this out quickly for the 1 mark. Okay, so we've got 13. Now that horrible decimal, remember we're going to call that A, and then we just times that by 24. But then remember, once we got our answer, don't forget to divide by 2. So we're getting 2,370.99. Don't think I wrote the divide by 2, so let me just pop that in the working. So remember, we did divide by 2 for a triangular prism. So we've got 2,300. Let me look at this again. 70.99. So easier when you've got the calculator right at the side there. 0.99, ... And again, we'd round this to 3 significant figures. So it's going to be 2,370. Okay, and on to question C. So I want to calculate the angle that AF makes with the base BCFE. So the key thing to do here is make sure you label that correct angle. Okay, now we're going to come back to why this right angle is so important a bit later on. But let's have a look at what it actually wants us to do. So we've got our line from A to F, and we want to work out the angle it makes with the base. So in fact, what we're looking to do, so if I draw a line across like so, what we're actually trying to do, and it helps if I draw a completely straight line across, is actually look for this angle here. Now at the moment we're missing a bit of information. We have the opposite side over here, 13, but we need something else in order to work out what, this particular angle. Now we can actually work out this side here, which I try and do is a bit straighter than I did last time. We can actually work this out by using this right angle triangle. Now again, we like to do this in one simple calculation. So we're going to use Pythagoras using the 20 and the 24. So if we want to work out the length of AF, we can do this in a smooth calculation of the square root of 20 plus 24 squared. 20 squared plus 24 squared, exactly like this. Now at the moment I don't really need to do too much with this. I could work it out with a calculator. All I need to know is this term, so I can use normal SOHCAHTOA a bit later on. So what I've got now is I've got this term for AF, I've got the opposite, I can now use SOHCAHTOA. Now I've got the opposite and the hypotenuse, so I can use sine. So let's call this F as the angle. So to work out sine F, I do opposite over hypotenuse. Well, the opposite was 13. Hypotenuse is what I just worked out, so the square root of 20 squared plus 24 squared. And remember, to work out what the F angle actually is, the opposite of sining something is the inverse of sine. So I want to do sine inverse 13 divided by the square root of 20 squared plus 24 squared. So let's go over to my calculator and pop all this in. So let's put this in, make sure it's set in degrees. So we want to find the inverse sine. Let's get our fraction button ready. 13 is our opposite. And then we have this square root calculation. Notice by not using my calculator too early, I get the most accurate answer that is possible. I press enter and I get my final angle here of 24.589. Again, I'm going to show the examiner that I've worked this out precisely. So 24.589 ... And then we want to round this to 3 significant figures. So it's going to be 24.6 degrees, like so. So you can check your answer on what I've done here. One of the biggest mistakes that's made on this kind of question, this is always something you should consider as IGCSE students, where can I make mistake, is looking for the correct angle. Notice this is our angle that we're looking for, not the angle that goes all the way and hits the 24. So just be very careful exactly what kind of angle the question is looking for. That is where you can make the biggest mistakes. And number 5 is expanding and factorizing, including algebraic fractions. I'll go through a couple of questions to show the typical skills that you're expected, mostly on paper 2, but sometimes on paper 4. Okay, and now we're going to go through some very typical expanding and factorizing. So as soon as you see this word, it wants us to factorize completely. It means put in brackets. So whenever you see this word factorize, it means put into brackets. Now, how do we do this with this expression? Now, the first thing I notice here is they both share an x. So one thing I can do here is put this into a single bracket where I take a factor of x out. Now, you can kind of work backwards to expanding here. So what do you multiply x by to get x cubed? That's going to be x squared. And what do I multiply x by to get minus 16xy squared? Well, everything not x, so minus 16y squared. And now at this point, something should go off in your mind, alarm bells. Notice this is a square number. This is also a square number, and this is a square number as well. And that means we can use a really smart trick. This is called the difference of two squares, DOTS. What do I mean by this? Well, if I have two square numbers and I have a difference of them, so a minus in between, then I can write it as x minus y. I'm almost going to give you the answer there, x plus y. Now, how does this work here? Well, it's almost the same calculation, apart from we have a 16 rather than just y squared. But remember, the square root of 16 is equal to 4. So we can still take this very similar approach. So we've got our x outside, we set up our double brackets, and we can use this form. Well, square root of x squared is just x. We have a minus and a plus, doesn't matter which way round. Let's work out what goes here. Well, the square root of 16 is 4, and square root of y squared is y. So we get this form here, x, open brackets, x minus 4y, x plus 4y. And that is going to be our answer, so we're going to write it in nice and clearly. If you're in the exam and you have time, then by all means use FOIL to expand out the bracket, times everything by x, and then you can check there whether you actually get the same answer. Remember, expanding and factorizing are opposite operations of each other. Now let's look at a more difficult kind of question for 4 marks here, and we need to simplify this algebraic fraction. Again, your first thought should be to factorize in some way. Now I'm going to use a sneaky trick. The first thing I'm going to look at here is a denominator, because it's easier to work with. And I can take a factor of x out. So notice I can put x, open up a single bracket. What do I multiply x by to get 2x squared? Well, 2x. What do I multiply x by to get minus x? Well, just minus 1. Now the trick here is this bracket, generally speaking in these kind of questions, this is where you're building up your experience, this here is going to cancel with something above. So this here, this 2x minus 1, this bracket is going to cancel. So just keep that in mind as we do the top part, the numerator of this fraction. Now this is written out in the so-called 4-term way, and as soon as you see it like that, you need to divide it into 2 problems. So you've got 2x, let's not use the highlighter here, better to use the pen. So we've got 2x minus 1, and then let's put this separately, minus 4a x minus 2a. Now we've got a factor of 2x minus 1, so what we really want to do is try and achieve 2x minus 1 from this in some way. What comes to mind? Well, we can take a factor of a out. We could also take out a minus 2 because we want this to be positive here. So my temptation here is to take out minus 2a. And the more experience you get at this, the quicker this process is. Now we work backwards here. What do you multiply minus 2a by to get minus 4ax? Well, 2 times 2 is 4, so we need a 2, and we need this x. Perfect. What do we multiply minus 2a by? Sorry, this is a plus 2a, that's important. What do you multiply minus 2a by to get plus 2a? Well, minus 1. So we've managed to factorize this, so we get minus 2a, open brackets 2x minus 1. So what we can do at this point is just copy across the 2x minus 1. So I'm just going to put that into a bracket, and then we can copy across what we've just created here. So minus 2a, open brackets 2x minus 1. Now at this point I'm going to actually factorize the numerator here, because they both have 2x minus 1 in common. So what I'm allowed to do here, which might seem a bit strange if you're not used to this factorizing, is I can take a 2x minus 1 as my first factor, and then anything in front of the bracket I bring as my second factor, which in this case is 1 minus 2a, like so. So I get a very convenient factorizing here. And once you know this idea, once you know this trick, this 4 marks is actually pretty easy to get. So once we've done that, we can cancel the 2x minus 1s out. And then we're left with our final answer of 1 minus 2a over x, which is our final answer. So in some ways, it doesn't really deserve 4 marks, but there's lots of things to notice here. We've got this weird factorizing that we did in the numerator. We have to factorize the denominator and find that common factor. Remember, use the easy factorization at the bottom to make you think, okay, I need that common factor also in the numerator as well. So you can check through the 2 questions I've gone through here as well. And now we're going to do some more straightforward expanding and simplifying from paper 2. So remember, when you are expanding with brackets, we need to be very, very careful with negatives. And remember what I love to call the hook. Now, why do I call it the hook? Because it looks like a hook. That's why. It means we're going to do 6 times t and 6 times minus q. So 6 times t is 6t. 6 times minus q is minus 6q. And we're going to use the hook again. Double hook. Sounds like a boxing match, doesn't it? To actually expand this. So minus 2 times t is minus 2t. And this is where I have to be really, 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 really careful, because minus 2 times minus 3q is plus 6q. That's really, really important to understand. Now at this point we can collect up like terms. So we've got 6t here and minus 2t there. So we have 4t in total. And then we have a minus 6q plus 6q. Well, that just disappears. So that's very, very handy. So this is going to be here our final answer. So we pop in to the answer space as always, 4t. Now let's look at our very last questions. Okay, we've got a little bit of work with quadratics as well, but this is also important generally speaking. So this falls between the quadratic area and also the expanding and factorizing. Now, if you want to factorize this completely, when you've got 3 terms here, so an x squared term, an x and a number, then we're going to put this into 2 brackets. This is a fundamental part of your course. We put an x at the start of both. And then we want 2 numbers that multiply to give you minus 28, but they add to give you minus 3. And the best way to think about this is to write down all the factor pairs of minus 28. So, for example, we could write down 1 and minus 28, or the other way round, so minus 1 and 28. We could also write down minus 2 and 14, minus 14 and 2. We also have, what else also fits in? 4, yeah, minus 7, and minus 4 and 7. So that's all our factor pairs. So we've got 6 possibilities here. And now we need to work out, if we add them together, which one makes minus 3. Well, it's going to be the one in the top right-hand corner. It's going to be this one, because 4 minus 7 is equal to minus 3. So we found our correct answer. Once we do, you can put it into your bracket in any order. You think at some point I'd learn not to use the highlight, so we get plus 4 minus 7. Okay, so we get x plus 4 and x minus 7. So we pop that answer in like so. And question 2 is a little twist on the previous question that we saw. Now notice here, both of these have an a plus 2b in common. So we can do a very similar trick to what we did before. Imagine I take out this factor, a plus 2b, and now I cross out this factor. So a plus 2b squared, so we have left a plus 2b. And then whatever's left goes into our second bracket. So we have 7, open brackets, a plus 2b, plus 4a. And at this point, all we need to do is simplify that right bracket. So we get a plus 2b. Let's expand this out using the hook. So we get 7a, 7 times a is 7a, 7 times 2b is plus 14b, plus 4a, and now we've got a little bit of like term stuff to work with here, because remember 7a plus 4a is equal to 11a. So remember, we have to do it completely, important word, which means we have to get it all the way to that final answer. So if we factorize this, we get a plus 2b and 11a plus 14b, just like so. So you can have a look at the two answers I've just gone through. Expanding and factorizing is a very important topic, more so on paper 2 than paper 4. But again, it's a fundamental part of the IGCSE 0580 syllabus. And on to statistics, number 6, which generally takes the form of cumulative frequency, histograms, and then some kind of estimate of mean question. And that's exactly what I'm going to go through now. Okay, and now let's go through a very typical stats question on the 0580 course. And this is a great question because we combine some cumulative frequency with some histograms a bit later on. So Zoe's test scores last term were the following. We don't know if it's marks or percentages or anything, but it doesn't really matter for this question. And first of all, we want to find the range. So remember the range, what this is equal to is the biggest minus the smallest. Now, luckily for us, it is already in order. So we've got 10 as the biggest, we have 6 as the smallest. So it's going to be equal to 10 minus 6, which is equal to 4. Now, the mode, remember, you need to know these key definitions on your course, is the most common number. So that's what the mode is. It's the most common number in our collection of test scores. And you'll see we've got 3 lots of 7 compared to every other number. So that is the most frequent number. So we've got 3 7s, therefore our answer is going to be 7. For the median, so median, remember, this means the middle number. Okay, when we put them in order. Now, luckily for us, the numbers are already in order. So the way we do this, we cross off the bottom, we cross off the top. We cross off the bottom, cross off the top. Cross off the bottom, cross off the top. Cross off the bottom, cross off the top. And we see that our middle number here is equal to 8. So we pop that in. If you had 2 middle numbers, then you find halfway between those 2 middle numbers. Okay, on to part B. So the cumulative frequency diagram shows information about the time taken by each of 200 students to solve a problem. And we need to use the diagram to find an estimate of the median. This is usually given within a range. So let's work that out here. So the median again is the middle. So notice we've got 200 students in total. So the median approximately, I'm going to use this, hence it's an estimate, it's going to be half of that. So it's going to be equal to 100. So we go to 100, we just draw a horizontal line all the way across, try to be as accurate as possible, and I'm trying not to get dizzy eyes here either, and then we read downwards from there, and you'll see that we get our number of 14. Now the interquartile range is a bit more complicated. So interquartile range, IQR, interquartile range, is equal to the upper quartile minus the lower quartile. Now you're probably thinking at home, okay, what does even upper quartile and lower quartile mean? Well, lower quartile is 1/4 of data, which we'll work out in a moment, and the upper quartile is 3/4 of the data. So for the lower quartile, we want 1/4 of the data. So we want 1/4 of 200, that's equal to 50. And for the upper quartile, we want 3/4 of the data, so that's equal to 150. So let's do some color coding here. Let's do our lower quartile in blue. So we go to 50 here. Now look at the scale very carefully. So 50 is going to be halfway between this box here. So we go across. Again, much easier to do with a ruler. And then we go down. I'm going to say that's equal to 11. I think that's a reasonable estimate. And now we do something very similar. So let's do this in a different color. Let's do this in green. So I'm going to go to 150 and do exactly the same process. So you go across. And it's very, very typical on this course. You need to understand how to use a cumulative frequency graph. Sometimes I'll ask you also to actually fill out a table as well. So a cumulative frequency table too. So if I go down here, I get there eventually. I think that's 15. So let's pop in 15 over here. They don't give you much room for error on this particular course, so just be careful. And now if we do the calculation, well, this is going to be 15 minus 11, which is equal to 4. So we can put 4 in there. Now this is a very typical paper 4 question, lots of different skills here within this statistics question, and this is no different. So now we need, the test scores of 200 students are shown now in a table, and we need to calculate the mean. Now the way that we do this is create an extra row at the bottom, and this row is going to be score times frequency. So what we're going to do is take the two numbers that we have here and multiply them together. So 5 times 3, that's equal to 15, 6 times 10 is equal to 60, and so on. And let's use the calculator now. I don't think I have a calculator here by my side to actually work out the other numbers. So we've got 43 times 7, so that's equal to 301. So as we go along, maybe I can just draw on here, make it quicker. This is 301, and back to the calculator, 75 times 8. So we're just working out all these different numbers here, so 600. So this is going to be 600, 48 times 9, times 9, 432. And lastly, this is 210. What we're going to do with those numbers is we're going to add them all together. So we're going to do 15 plus 60, etc. So let's do that on the calculator. So 15 plus 60 plus 301 plus 600 plus 432 plus 210. Let's double check that's correct. It is. So if we do that and press enter, we get 1618. So let's pop that in. And so to work out the mean from this, we do 1618 divided by the total number of students, which is 200. So we're going to take that answer and divide by 200. That gets us to, I don't like fractions, so let's get a decimal. Okay, that didn't work out as I anticipated, so 809 divided by 100. You can press Control Enter here to give you a decimal, but we can see this is going to be 8.09, so let me just pop that in. So this is equal to 8.09, which is going to be our final answer for 3 marks, like so. And the last question is an interesting one. I like this. This is why I picked this question out, which mixes up our knowledge of estimate of means, but also with histograms. So remember, this is a histogram, which is also known as a frequency density bar chart. Okay, and the key thing to remember as soon as you see this word histogram is that the area of bar equals the frequency. That's really, really important. So as soon as you see histogram, it's the area of the bar that tells you the frequency. And we need to work out an estimate of the mean height and show all our working. So this is a little bit complicated. We've got a lot to work out here. So first of all, we need to work out the areas of each of the bars. Well, this is equal to 1 times 30. Notice the height here is 1. The length of this is 30. So 1 times 30 is 30. This one here, we've got a length of 20, a height of 3.5. So what's 20 times 3.5? That's going to be equal to 70. And then this one, we've got 10 times 4. That's equal to 40. And the next one, that's 10 times, okay, let's be careful with the scale here, so 3.1, 3.2, 3.3, 3.4, 5, 3.6, so this is 3.6, so 3.6 times 10, that's equal to 36, the last one here, this is 40 going across times by I'm going to have to check this quite carefully here. I think this is 0.6. So 0.1, 0.2, 0.3, 0.5, 0.6. So this is 0.6. This here is equal to 40. And if we do 40 times 0.6, that is equal to 24. So this is going to be equal to 24. So if we wrap this up in the way that we've done before, our frequencies here, it's important to show the examiner. So we have 30, 70, 40, 36, and 24. Now we need to work out an estimate of the mean. So what we need to do is take the midpoints of each of these categories. So the midpoint between 50 and 80, halfway between those numbers, that's going to be 65. Halfway between 80 and 100 is 90. Halfway between 100 and 110 is 105. You probably see the pattern here. Next one's 115. And then last one, halfway between, is 140. And in a similar way to how we did the previous question, I'm going to call this M for midpoints. We need to work out F times M. So we need to multiply these together. So again, let's go to my calculator and work this out. So let's start with 30 times 65, that's going to be 1,950. 950. 80 times 70, that's 5,600. Some of these you can do in your head. 40 times 105. Probably could do this in my head. But we've got a calculator. 4,200. And 115 times 36. Again, we need big questions. You just need to be really, really accurate. And just take your time. 4,140. 140. And then 140 times 24. 140. 24 is equal to 3,360. So let's pop that in. And like before, we need to add all these numbers together so we can work out a total. So let's do that on the calculator now. So 1,950 plus 5,600 plus 4,200 plus 4,140, 3,360. 1, 2, 3, 4, 5. Got 5 numbers. Just double check. Always double check. Yep, I'm happy with that. 19,250. 19,250. And so our estimate for the mean is going to be 19,250 divided by 200. Remember, we've got 200 plants in total. Don't forget that important piece of information. So if we take 19,250, divide that by 200, enter, we get a weird fraction. But that's going to be equal to 96.25, which is incorrect. So if this happens in the exam, what you need to do is check over exactly what you've done here. So it looks like we've done the right calculations. 30 times 65, 70 times 90. So again, this shows you a very important part of the process here. And I've included this in the video on purpose, is that when you actually make this unclear and you can't read your writing, then you need to make sure you double check. So this is actually equal to 90, which means this is going to be equal to 6,300. And let's go back and edit that on our calculator. So we're going to do the similar calculation here. The only thing that we're missing is this is 6,300. This is why writing your working very clearly at every stage is really, really important. So double check again. We've got 5 numbers, all the same apart from this one's now changed. Press enter. We get 19,950. 19,950. So this is going to be a 9. And now we do the same calculation. So 19,950. I think it's important to see that things don't go right immediately. you need to be willing to change. So good, we get 99.75, which is going to be our final answer. Okay, so you can see all the working done and all the process that I've gone through. If you didn't get the last part, there is the working for question D. Statistics is a really important part of the course. You can't guarantee it's always going to be on paper 2 or paper 4, but you know it's going to appear in a pretty big way in some form. And number 7, moving away from quadratics, is equation solving generally. So this could be linear, this could be simultaneous, or a mixture of both. So I'm going to go through a couple of those examples. Okay, and now we're going to go through some equation solving, which is going to be a fairly short area, but at the same time, it's very important you can deal with simultaneous equations like you see in front of you, but also look at quadratics when they arise as well. So I did already a separate section on quadratics, but this is now more from an equation solving point of view. Right, let's look at question 5a. So we need to solve the simultaneous equations x plus 2y and x plus 5y is equal to 22. Now generally we want to get either the x's or the y's the same. That is our strategy. So x or y the same. Now in this example, this is actually an easier example here where the x's are already the same for us. And by taking one equation from the other, we can then get an equation just in terms of y. But we need to be really careful how we do this. So x minus x, well that disappears, that's 0. 2y minus 5y, that's minus 3y. This is where negatives, you need to be really, really careful. And then 13 minus 22, that's going to be equal to negative 9. Again, you've always got your calculator there. If you're unsure with any of these calculations, please use it. Now, we want to get y on its own. So what's the opposite of timesing by minus 3? Well, we need to divide by minus 3 on both sides. If we do that, this cancels. We get y is equal to, well, minus 9 divided by minus 3. That's equal to positive 3. However, we are not finished with this question. One of the worst things you can do here is start celebrating and go, yeah, I'm done. We have to work out x as well. So we need to substitute, so replace the y into either of these equations. Doesn't matter which one we choose. I'm going to sub in 1. So I'm very clear to the examiner. I'm putting it into equation 1. So I'm going to copy out equation 1. Wherever I see a y, I'm going to put a 3. So 2 bracket 3 equals 13. And now we just got the simple calculation here. So 2 times 3 is equal to 6. And now we want to get the x on its own. So what's the opposite of adding 6? Well, we want to minus 6 on both sides. This cancels, and we get x is equal to, well, 13 minus 6 is equal to 7. Making sure I've got very, very clear working as I go through. So make sure you put the right answer in the right place. X is 7 and y is 3. Please don't be that student who puts them the wrong way around. Please don't do that at home. Now we go on to, essentially this is a quadratic simultaneous equation, but it's set up in such a way that makes our life a bit easier. So y is equal to 2 minus x, and y is equal to this x squared plus 2x plus 2. So if these two things are both equal to y, we can say that the right-hand sides are also equal. So from here we can go then that 2 minus x is equal to x squared plus 2x plus 2. Now before I do any manipulation, I like all my x squareds on the left-hand side. So I'm going to flip over the equation like so. And now I'm just going to take it one step at a time and make sure I get to a quadratic I can solve. So the first thing I'm going to do, I'm going to add x on both sides. The effect this has, the x squared stays the same, 2x plus x is 3x, plus 2 stays the same, plus 2 stays the same, and minus x plus x, those cancel. Super. And now I'm going to take away 2 from both sides. Just keep chipping away at the equation until we get something simpler. Right, x squared stays the same, 3x stays the same, 2 minus 2 cancel, fantastic, and then 2 minus 2 is equal to 0. Now this is a special form of solving a quadratic where we have no number term, and it's often something that students forget, hence why I've chosen this question. So the way we actually solve this is factorize into a single bracket instead. Now what do these two things have in common? Well, they both have an x in common, and then we work backwards. So what do we multiply x by to get x squared? Well, that's just x. What do we multiply x by to get 3x? By 3. And now we use what's called our Null Law. So when you have two things that multiply to give you 0, either this is 0, or, let's underline this in, probably not red, not a good idea, or this is 0. So if a times b is equal to 0, then either a is 0 or b is 0. This is our so-called Null Law or Zero Law. Now if we apply it to this question here, then either this green part is 0, so x is 0, or this blue part is 0, so x plus 3 is 0, and therefore x, in order for this to be true, must be minus 3. And just like in my previous question, do not celebrate at this point. We still got some extra work to do. 4 marks, I'm not going to give it to you for free. So we're going to substitute back in one of our equations. Generally, the linear equation, the top one, is the easiest one to do. So now we're going to sub in 1. Now when x is equal to 0, y is equal to 2 minus 0. So that's equal to 2. Let's pop that in. And then when x is equal to minus 3, be careful with negatives, always careful with those negatives. 2 minus minus 3. 2 minuses make a plus, and 2 plus 3 is 5. So just be very careful with your algebra skills, be careful with your negative numbers with these questions, and just take your time. If you get 4 marks, that's going to give you roughly about 5-6 minutes to do the question. Make sure you use that time effectively, and, it's my slogan, learn and do it efficiently as well. So you can check the answers that I've done here. I've done method 1 here for this question here, and you can see where you pick up your method marks. Equation solving, important skill, both paper 2 and paper 4. Make sure you master it. Number 8 is differentiation. So I'm going to include one question here, but if you want more depth on this particular topic, then do check out the video above. Okay, and on to some very typical paper 4 questions. And so we're going to look at this one here. As you can see, it's out of 8 marks, so it's going to take a little bit more work. So first of all, we want to work out dy by dx of this function here. So the way we do that is just like we did on the paper 2 questions. So we take the 3 here, we bring it to the back. So 3 times 2 is equal to 6. We reduce the index by 1, so it was an x cubed, and now it's going to become an x squared. And likewise for this part here, we're going to take the 2 there, we're going to bring it to the back. Minus 4 times 2 is equal to minus 8. We reduce the index by 1, so this becomes x to the power of 1, or as we like to write, just x. And that's all we need for our derived function. Remember, if you differentiate the 6, then the gradient of that is 0, so that will disappear. And now this is very typical in the part 2. We want to work out the gradient at a specific point. So we want to work out the gradient when x is equal to 4. So we take our initial answer here, so 6x squared minus 8x, and replace the x with 4. So we get 6 lots of 4 squared minus 8 times 4. And remember our bid mass, so 4 squared is equal to 16. 8 times 4 here is equal to 32. And now we just need to do this calculation here, so 16 times 6. Now, again, we've got a calculator, but again, you can always do it manually this way as well. This gives you 96. So then 96 minus 32. Again, any of this can be done on your calculator as well. And this gives you the final answer of 64. So the gradient at that particular point is equal to 64. And this is a good question to go through because it goes through a lot of the typical kind of paper 4 style differentiation questions. And we want to work out the coordinates of the two stationary points on the curve. So as soon as you see the phrase stationary point or turning point, you need to be thinking that the gradient function, that's a T, gradient function is equal to 0. Well, what does that mean? So we take our initial function here, our 6x squared minus 8x, and make it equal to 0. So you need to have good quadratic skills as well in order to be able to do these questions. Now here, this is an example of where we factorize into a single bracket. So what do these two things have in common? Well, they've certainly got a 2 in common, and they have an x in common as well. So then we open up our bracket. What do we multiply 2x by to get 6x squared? Well, that's going to be 3. 3 times 2 is 6, and an x. What do we multiply 2x by to get minus 8x? That's going to be minus 4 is equal to 0. And just like we did in one of the paper 2 questions, we use our null law. So when 2x is equal to 0, so we know one of these things has to be 0, we don't know which one. Well, x is equal to 0, and when 3x minus 4 is equal to 0, well, 3x is equal to 4, x is equal, oh no, so near the bottom of the page, is equal to 4. It doesn't want me to write it, I'm going to write it over here. See, there we are. 4/3. That is going to be 4/3. There we are. I'm determined to write it. Here we are. So x is equal to 4/3. So that's our x coordinates of the turning points. So 0 and 4/3. And now we need to work out the y. So we need to take our function right up here. So this is equal to y equals 2x cubed minus 4x squared plus 6. And now we need to replace the x in here with these values of 0 and 4/3. So let's start with 0. So when x is equal to 0, y is equal to, well, that disappears. That's cool. This also disappears. That's even cooler. And we've got the plus 6. So these all disappear, and we're left with just 6. So our first turning point, or our first stationary point, is equal to 0, 6. Next one's going to be a little harder. So we're going to go to when x is equal to 4/3. I'm going to just write this out for the examiner. So we've got 2 lots of 4/3 cubed minus 4 lots of 4/3 squared plus 6. Now this is one where I certainly wouldn't work this out in my head. So I'm going to go to my calculator and work it out there. So we've got 2 open brackets fraction. Again, I'm using the 0607 calculator, but again, any Casio is fine for this process. And we've got a bracket. Oh, too many brackets. Cubed. So I'm going to use this button here for cubed. Minus. Let's just remind myself what it is. So it's minus 4 open brackets. Open brackets, 4/3 squared plus 6. Press enter, and then you'll generate your answer of 98/27. So this is where the calculator is very handy to work out these more complex calculations of fractions, and that gives me the y coordinate of the other turning point, like so. So there's the mark scheme, so you can have a quick look through and where you actually get the marks and what some of the method marks are dependent on as well. Okay, on to the next question. So again, this is very, very typical of the paper 4 and the 0580 course. They don't start necessarily with a differentiation problem. It's usually embedded in another question. So in this case, the equation is cubic, x cubed minus 4x squared plus 4x can be written in this form. Find the value of a. So
Cubics, generally speaking, will be written in such a way so you can factorize this quite easily. So notice they've all got a factor of x here. So we're going to take a factor of x out. What do you multiply x by to get x cubed? X squared. What do you multiply x by to get minus 4x squared? Minus 4x. What do you multiply x by to get 4x? It's just plus 4. At this point, we've got a quadratic within the bracket. So at this point, we can put this into two brackets. And we put an x at the front, an x at the front. And we want two numbers that multiply to give me 4, but add to give me minus 4. Well, that's going to be minus 2 and minus 2. And notice, because you've got two x minus 2's, this can be simplified further as x minus 2 squared. Now, that's not the answer that they're looking for. The actual answer is, what's this missing value a here? And notice it's the value of 2. Now, one of the reasons they've done this in the first part is now we can now draw a very nice sketch. So if I was to solve this equation, so let me pop this over here. So x over x minus 2 all squared times x minus 2 all squared is equal to 0. Then using the Null Law, I know then that x must be either equal to 0 or equal to 2. However, this is a cubic. So remember that the shape of a cubic, generally speaking, looks something like this. So it crosses the axis 3 times. This is a very special cubic where it only crosses or touches the x-axis twice. So let's mark in those turning points. So we've got 0 here and 2 over here. We have a positive cubic. Notice this is an x cubed. And so we've got all the information we need to draw a good sketch. So watch carefully. We're going to go up, 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 up. We go through the point, and this is the crucial part. Because the 2 is a repeated root, we're just going to touch the graph there, and then we go off. That's a little bit of a bend there. Try and make sure that's a nice smooth curve as well. Okay, so notice that I've followed the instructions of the question, where the graph meets the axes, where it meets it at 0, 0, meets at 2, 0 as well. But there is some sort of local maximum, but that's not necessary for this question. You'll see in the mark scheme, if I go forward to the mark scheme. So here's your graph. So it's going through the origin, going through 2, 0, the positive cubic, and it's the right shape as well. So you can see I pick up all 4 marks. Now comes to the differentiation part. So they take that cubic, and we want to find the equation of the tangent to the graph at x equals 4. So what that means in real English is if I take green, x is 4 is probably up here somewhere. Okay, so if we read that off, that's 4. So basically at that particular point we want to find the tangent line. So the line that just touches the curve and then disappears off. So this really, really steep line. And we want to find that equation of that particular line. So the way we do this is we use some differentiation. This is where it's embedded. So first of all, we need to differentiate the function. So we get dy by dx. So remember, we take the 3, bring it to the front, reduce it by 1. So we get 3x squared. We do the same procedure here. I'm speeding up slightly now. So minus 4 times 2 is equal to minus 8. Reduce the index by 1 is 8x. And don't forget, because you've got a 4x here, we do the same procedure because this is a 1. 1 times 4 is 4. And then reduce the index by 1. That's x to the power of 0, which is just 1. So we get the function of dy by dx is equal to 3x squared minus 8x plus 4. Now at this point, we actually want to work out the gradient at the specific point. We don't want to work out turning points or anything. So we need to work out d by dx, where x is equal to 4. What does that mean in real English? Well, we're going to put 4 into this equation. So we get 3 lots of 4 squared minus 8 times 4 plus 4. Well, 4 squared is 16. 16 times 3 is 48. 8 times 4 is 32. Plus 4, and that simplifies to 20. Okay, so the gradient of that green line that I drew over here, let me just mark this in, the gradient of this line is equal to 20. So we've got that information. Now that means that the tangent line, so I'm going to write the word tangent, has the form y equals 20x plus c. And now we need to work out the y-intercept, this c. Now the only point that we know on this particular tangent line is this point here. Okay, and we know the x-coordinate is 4, but we currently don't know what the y-coordinate is. The way we can work that out is actually substitute x equals 4 into this equation. So when x is equal to 4, y is equal to 4 cubed minus 4 lots of 4 squared plus 4 times 4. That's a lot of 4s. That is definitely a lot of 4s. So we get 4 cubed is equal to 64. Well, 4 squared is 16. 16 times 4 is 64. Oh, that's nice. That cancels. And then we get 4 times 4 is 16. So when x is 4, y is 16. So this coordinate is actually 4, 16. And now we have enough information to work out c. So when x is equal to 4, y is equal to 16. You can see why this is a 7-mark question. A lot of work involved. So we've got 16 equals 20 lots of 4 plus c. So 16 is equal to 80 plus c. And then c is equal to 16 minus 80. This is really where you don't want to make a silly mistake, by the way. So 16 minus 80, that's equal to minus 64. So our final answer is equal to y equals 20x minus 64. And you'll see that agrees with the final answer at the end for all 7 marks. So just be very careful of that kind of calculation right at the end. You're going to be tired at the end of a question like this. Make sure you're accurate all the way until the end.
And number 9 is volume area of 2D and 3D shapes, perhaps the most important topic on the whole 0580 syllabus. I'll go through a very typical question that involves some volume calculation, surface area, and then tying that in with a little bit of trigonometry in there as well.
Okay, let's go through a typical IGCSE 0580 question on volume and surface area. So we have a cuboid, it measures 20 centimeters by 12 by 5, and we need to calculate the volume. So if I do a quick sketch, again, not to scale in any shape or form, but just to give us an idea of what this looks like. So this would be 20, this would be 12, and say this would be 5 in any order. Now to work out the volume, remember the formula for the volume of a cuboid is base times width times height. So if we times these things together, now we could use a calculator to do this, but I'm going to do this without a calculator. 12 times 5 is 60, and then 20 times 60 is equal to our answer of 1200. Again, calculator paper, you can type this into your calculator. Now the surface area is a little bit more tricky, and the way I generally teach this is as follows. The first thing I like to do is work out the area of all the sides I can see. So notice we can see 3 of the 6 sides of the cuboid. The front one, the top one, and the one to the side. And I like to work out the area of each individually. So if we take the one at the side here, well, that's going to be 12 times 5. So that's going to be equal to 60. If we take the one at the top, that's going to be 20 times 12. So we're looking at this one here, 20 along and 12 here. So 20 times 12, that's going to be equal to 240. Again, you can put this into a calculator, not a problem. And then finally, we've got the front one here, which is going to be 20 times 5. So we work out each of the sides we can see. Once we've worked out those, we're going to add those together. So if I add together 240, 60, and 100, that's going to give me the answer of 400. But that's not the final answer, because the total surface area, remember, for the front side, we've got the one around the back that we can't see. For the top, we've got the side at the bottom that we can't see. And likewise, the one at the side, we have the one on the other side. So once we have our answer of 400, we want to double that to make sure we include the sides we can't see, and then that leads to our answer of 400 times 2 is equal to 800. quite generous giving you 3 marks there. I would give 2 personally, but there we are. That's absolutely fine. Take the marks. So the surface of the cuboid is painted and the cost the paint used is $1.52. Pretty cheap. And find the cost to paint 1 square centimetre of the cuboid and give your answers in cents. So it costs $1.52 to colour the whole thing. The whole thing is 800. We want to work out one of those, so we need to divide by 800, which is the important part. Notice it's a 1 mark question, so it should be a relatively easy calculation. Now, let's go to my calculator and quickly work that out. So we type in $1.52 and we divide by 800. Give us the answer of 0.0019. But let's think about that for a moment. So we get 0.0019. Now remember, this is in dollars. We want this in cents, so we need to divide that by 100 cents in a dollar, and then that will give us our final answer of 0.19 cents. So just be careful with the units here and make sure you've got the appropriate units. We don't want the answer in dollars, we want it in cents. On to question B, and we're given a random solid metal cylinder. So let me draw a cylinder. Do like drawing, that's one of the great fun of mathematics. You can just sketch things the entire time. We have a radius of x, okay, so our radius is x, and the height of this is equal to 9x over 2. Good, and all this metal is going to be melted down to make a sphere. Now I'm terrible at drawing spheres, but it will look something like this, where this is the radius r, and we need to find r in terms of x. Right, so the first thing we need to do is work out the volume of the cylinder. Now remember, the formula for this is equal to pi r squared, so the area of the circle times the height. So if we use x instead, we're going to have pi times x squared times 9x over 2. And we can simplify this down slightly, so let's make it a little bit neater here. So this could be pi, or x squared times x is x cubed. We've got a 9 as well still here, so I'm going to put it out the front. And then we've got the divide by 2. So this step here, I'm just tidying up the algebra. And what we're told is all that metal is used to make this sphere. Now this sphere has the formula of V equals 4/3 pi r cubed, which we could write slightly differently here of 4 pi r cubed over 3, which you'll see why this is useful a bit later on. And we know that these two volumes, so this volume here and this volume here, are equal to each other. Okay, the same amount. So what we get here, we want r in terms of x, so I'm going to put the r stuff on the left hand side. So 4 pi r cubed over 3 is equal to 9 pi x cubed over 2. Right, the first thing is, can we simplify? And simplify we can. So we can cancel pi from both sides. That's great. We can cancel the 4 and the 2. So 2 goes into 2 once, 2 goes into 4 twice. And 3 and 9 also works. So 3 goes into 3 once. 3 goes into 9 3 times. This leaves us with, let's see what the wreckage leaves us. So we get 2r cubed. And we get on the other side, what are we left with? 3x cubed. Okay. So at this point, what can we do? Well, we can divide by 2 here. So we get r cubed is equal to 3 over 2 x cubed. And at this point, we can cube both sides. That leaves us our answer, r equals 3 over 2x. Let's double check that. Yeah, 3x over 2 or 1.5x. Perfect. Super duper. So we can write that in. 3 over 2x. On to part C, which is an interesting question. So using, there's a whopping 7 marks, by the way, so I'll just point this out. This happens occasionally on these big 2D, 3D questions. You can get a ton of marks for these. So we've got a diagram. It shows a cylinder of length 150 centimeters on horizontal ground. Cylinder's got a radius of 20. Cylinder contains water to a depth of 5 as shown. and work out the volume in litres. Right. Yeah, a lot to do in this question. My first thought is to take the front of this cylinder and let's just draw it out separately. So I'm going to draw a circle and we put the centre in. Now notice we've got this radius of 20, so I'm going to pop that in. So this is 20 centimetres. We've got this depth. We want to connect this up, so I'm just making sure my diagram's the same. We've got this dot, 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 dot. And this is not to scale, just put this very clearly, not to scale. So this is 5 centimetres here. It looks very sensible to put in a dotted line here. Now if this is a right angle, this needs to be a right angle, so that's useful. Okay, and I want to find out, let's use a different colour here. Let's use a bit of yellow. This area, yeah, because then we can times it by 150 at the end. We can actually work out this length here. Remember, this whole thing is also a radius of 20. So this length here is going to be 15 centimetres. Okay, I've got the right idea here at this point. So we can work out this angle first of all, which is going to be useful. So let's call that theta. If I kind of zoom in on this triangle, so let's zoom in on that. This is 15. I want to work out this angle, as you'll see later. This is the right angle. This is 20. This calls for some trig. So let's use, well, we've got adjacent side and hypotenuse, so let's use cos. So cos theta is equal to adjacent over hypotenuse, 15 over 20. So theta is equal to the inverse cosine of this. Now I'm going to work this out, but I'm going to store it in on my calculator so I can use it later on. So let's work out inverse cos. So we've got inverse cos, 15 divided by 20, close bracket, and we get 41.4096. Now on my calculator, you can do this on Casio's as well. I'm going to store this as a variable. So control store, I'm going to store this as A. So I don't have to write out all decimal places, etc. So I'm going to keep that stored. I'm going to write in what I got here, roughly speaking, just so the examiner knows what I'm doing. So we know the angle is 41.4. At this point, essentially, we've got one of these problems, which I'm going to sort of draw out now. So we've got arc, we've got the angle, which we know now. I'm going to say, okay, sorry about that. 20 centimeters, probably should edit it out. And what we have here is a straight line, and we want to work this area. This is the kind of area of a segment question, but we know a lot of the information. This is 15. This is not so important anymore, 5 centimeters. So we want to work out this area. Let's call this B, for example. So to work out B, what we need to do is work out the area of the whole sector. Now the way we do this is we take the 41.4 dot 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 divided by 360 times pi r squared, which is pi times 20 squared. It's the area of the whole sector, and then we minus the area of the triangle. Now remember, the area of a triangle is a half AB. Now be careful with this, because this is A and this is B. It's not the whole 20, it's 15 as well. So half times 20 times 15 times the sine of this angle of, hopefully this is clear, 41.4 dot dot dot. And so I'm going to put all this calculation, if you can't see it completely, I'm going to put all this into the calculator and work out an answer for this area B. So this is where the variable comes in very handy. So all I have to do is click on A here, once I've got a fraction. So this is A, this is 360, and so it will just store it, which is very handy. So you get times pi, again, your calculator might look slightly different, 20 squared, close bracket, minus, open bracket, 0.5, I'll use that, times 20, times 15, times the sine of the angle. Okay, so you really need to know your calculator. Again, I can use A to make sure I've got everything there. So I get a final answer from that area of 45.3312. So let's just pop that in. Okay, so I've got this area of 45.3312. The problem is that only gives me this area here. So I need to double that first of all. So the cross section, the whole cross section, is equal to 2 lots of B, so 2 lots of 45.3312, dot, dot, dot. So go back to my calculator and just times this answer by 2. So answer times 2, so we've got 90.6624. So just keep writing this down so the examiner knows, 90.6624, da, da, da. So we've got the cross section there. Now to work out the volume of this, we need to times that by 150. So the volume, which is what we wanted, is equal to, I will do this in one step, so 90.6624 times 150. Now the problem with that gives us our answer in cubic centimeters. Remember, 1 cubic centimeter is equal to 1 milliliter. So 1,000 cubic centimeters is equal to 1 liter, which is the units that we wanted. So we take that answer, whatever this is, and then divide this by 1,000. So I'm going to go to my calculator for the final time and pop this in. Okay, so we take our answer, times by 150, divide by 100, bit of maths will sort out the rest, and we get, I need to divide by 1,000, sorry, so I need to divide this by 10 again, and we get our final answer. There we are, 13.5994, so we pop that in. 0.5994. Notice we've got the most accurate answer possible, so no rounding errors. If you round this now, it's going to be 13.6 litres for all 7 marks. So just check the mark scheme as well, so you can see it here. So you can get 13.6. Again, if you round something different, that's not a problem. And you can see where you pick up all these 7 marks as you go along. A nice in-depth question, and one you really need to be able to master to really be happy with the IGCSE 0580 course.
And number 10, my very last topic, is probability and Venn diagrams, which I kind of put together here. And if you again want to check out more detailed questions on this, then check out the video above. But otherwise, I'm going to go through one very typical probability question. So a bag contains 3 blue buttons, 8 white buttons, and 5 red buttons. 2 buttons are picked at random from the bag without replacement, so the probability is going to change as we go through the problem, and work out that the 2 buttons are either both red or both white. Now, I do recommend a tree diagram to do this, but I do not recommend to fill everything in. So let's put this together. So here's my initial tree diagram that I'm going to draw, and we're going to have blue there, we're going to have white here, and we're going to have red here. And then the second choice will have the same options. So we'll have blue here, white here, red here, and the same for the other options as well. Now this looks quite bewildering at first, a bit crazy, like we have to work out everything, but we just need to think which situations we actually want to work out. So let's go through this. The first part is, well, how many buttons do we have in total? Well, we've got 8, 11, 16 buttons. So the probability of getting a blue button is 3 out of 16. Now I'm still going to write this as a unsimplified fraction, so 8 out of 16 here, and then 5 out of 16 there. And now we just need to consider the situations we want, which are 2 buttons either both red or both white. So the only solutions I need to find here is this one and this one here. Okay, so I'm identifying what I need. Now, to work out this one here, well, if I go down the blue route, I've already chosen a blue one. And I just realised I don't want to choose a blue one. I want to choose a red one and a white one. So we need to go down here and here. See, as you go through the question, you should check these things. And if it's not correct, then just change it as you go through. So let's go through the situations again. So we want both red or both white. Well, if we've got both white, let's start with white. So we've got 8 out of 16. Now we've chosen the white, so that's going to get reduced down to 7. And then how many buttons do we have now? Well, we're down to 15. So we start with 8 out of 16. We've chosen a white button. We don't put it back. There are 15 buttons left, and then we've only got 7 white in there. Now we go right back to the start. So we have 5 out of 16 that are red. And then we choose a red button. So we only have 4 red buttons left, and we have 15 in total. So we need to work out these probabilities. So we work out the probability of white, white. Remember, we multiply along the branches. So we do 8 out of 16 times 7 out of 50, which I'm going to leave for the moment. We do the probability of, not blue, I really want to find out blue. It's probably because it's at the top. It's interesting psychologically. Yeah? So the probability of red, red, which is what we want, is equal to 5 out of 16 times 4 out of 50, like so. So we get 56 on the top here. Now 16 times 15, I think I'll just use my quick calculator I've got here. That's going to be equal to 240. And notice we didn't simplify any fractions before for a very specific purpose. 5 times 4 is 20. 16 times 15 is equal to 240. And we want the probability of white, white, or red, red. So we're going to add those fractions together. So if we add those fractions together, we've got the same bottom number. So we get 76 out of 240. Now we can actually simplify that down. So we can divide top and bottom here by 4. And then we get our simplified answer of 60 on the bottom. Again, you can use your calculator for this. 76 divided by 4 is equal to 19. And we have our answer. So the key thing is, don't do what I did at the start. Make sure you're doing the red and white options and don't include the blue. Make sure you know the options that you want, and then from there you can actually work out the probabilities you need. So I hope that you enjoyed this series. Again, give it a like and subscribe to the channel if you want to see more content like this, and really do give me feedback. I've tried to keep this as short as possible because I know your time is tight and there's a lot to fit in with your revision. Best of luck for the exams, and of course, let me know how you get on in the comments below.